Dear students, so we are starting with our next topic, that is tidal energy and hydrogen energy. So these both sources are the renewable source of energy, or it is a non-conventional source of energy. So these energies are in, it is the part of your unit number 1, Introduction to Energy Sources and its convergence. So let us start with first tidal energy. So tidal power plant, or you can say a tidal energy, is harnessed from tides of the oceans. So tidal energy is obtained from tides of the ocean in the form of ebb and flow of the tides. It is in the form of ebb and flow of the tides. The tides that are created by using the gravitational interaction of moon and sun. Tides are created by the gravitational interaction of sun and moon with the rotation of earth. So we obtain the tides between there is a gravitational interaction between sun and moon when the earth get rotated, and because of this tides are created. It can be obtained or harnessed in sea. They are also obtained or harnessed in tidal rivers or estuaries. It is another part that is called as estuaries. So in some shorelines, water levels can go up to 8 to 12 meters due to drastic changes in water level. So this is first type of tidal energy, that is the tidal barrage is used in this case. That is in shoreline, the water levels can go up to 8 to 10 meter and there is a drastic changes in water level. So in this type we use a tidal barrage to uh, convert this tidal energy into electrical energy. Now, tides can occur once or twice in a day, depending upon the location. So, every day there will be a tide. It may be once or it may be twice. And the timing of tides fluctuates over the period of 2 weeks or so on. So, therefore, the tidal energy is harnessed in mainly three ways, or we can say we can obtain tidal energies using three ways. First one is by using tidal barrage, second by using tidal turbine, and third by using tidal fans. We convert this tidal energy into an electricity or electrical energy. Now we will see these three methods or three ways one by one. So first is the tidal barrage. A tidal barrage, it is very similar to our conventional hydroelectric power plant or power generation. In this method, there is a tidal estuary. It is blocked off with a dam or barrage. So there is a tidal estuary which form a dam or barrage, and from that we can uh, flow the water into that tidal turbine, and we can convert electrical energy into sorry, we can convert tidal energy into electrical energy. Then we have movable floodgates are there. So that is called as sluice gate on the dam that allows tidal water enters into that and it fills a reservoir. Once water reaches the maximum level, gates gets closed and the water gets trapped as shown in figure. So if you see, there is a sea. Next one is estuary, turbine and generator, and there are two ways. First one is tide coming in. So water from sea is passes through this estuary, that is a small dam like structure. Here we have a sluice gate is there, and after the tide goes out, the water level of estuary gets increased and the sea level is goes on decreasing. So once this estuary it is filled with tides, the gate gets closed, and we open this gate when we have to generate the electricity. So the head of water in artificial estuary is called as hydrostatic head. So this head, that is this level between this estuary level and this sea level, it is called as a head, H. That is height of height difference between two water levels, sea water level and estuary water level. So the head of water in artificial estuary is called as hydrostatic head, and when high head water return, it rotate the turbine blade mounted on a shaft, and this turbine blade it is coupled to the generator, and the generator generates the electricity using mechanical power or rotation of the shaft. So this is the first method or way by which we can convert the tidal energy into electricity. It is by using a tidal barrage. It is a barrage or dam like structure that is called as estuary. Now we'll see the second methods to convert uh, tidal energy into electrical energy, that is by using a tidal turbine. So a tidal turbine is another way to exploit this tidal energy. So tidal turbines are submersible wind turbine that uses water instead of air to turn the blades. In windmill or in wind turbine, we use air that will rotate these blades, and similarly, this rotor is connected to hub, and we get that shaft. And because of shaft, we convert that shaft into electric mechanical power into electrical power or electrical energy. So it is same as like wind turbine, or we can say windmill. So the tidal turbine, these are submersible wind turbine. They are the tidal turbines. They are deep set at 20 to 30 meter inside the sea or inside the ocean, and can be situated at a place where there is strong tidal flow will be there. It is situated where there is a strong tidal flow will be there. Because of the heavier density of the water as compared to air, the tidal turbine must build more sturdier than the terrestrial counterpart as shown in this figure. So if you see, it should be more heavier as density of water is very high compared to air. So this should be more heavier so that it will do not damage any other parts of this tidal turbine. The advantage of this tidal turbine, the advantage is of a greater density of water, and is that relatively large amount of power can be produced by using a relatively small current and small rotor diameter as compared to windmill. Again, for example, a rotor with diameter of 10 to 15 meter can generate 200 to 700 kilowatt of power. So very small diameter of a rotor, it can generate the large power because of there is a greater density of water. Whereas same power is generated by a wind turbine. For that we require a 45 meter of diameter. For same power production, we require 3 times more diameter of the rotor. Generally, this tidal turbine is function based at a flow rate of 7 to 11 kilometer per hour. So if tides are flow at a rate of 7 to 11 kilometer per hour, this tidal turbine is best suited. The main advantages of this tidal turbine, in contrast with wind turbine, is predictability. So this tidal turbine is predictable. So tides flow in and tides flow out every day. So there is everyday energy generation will be there. So it can be predictable. As like wind is not predictable, but tide is predictable. So once or twice in a day, there will be a tide, high tide and low tide, and because of that, there will be a power generation will be there. So this is the uh, conversion of tidal energy to the electricity by using tidal turbine. Now we have third way, that is the uh, tidal fence. So this is the tidal fence. It is not tidal turbine, it is tidal fence. So this tidal fence, it is an extension of tidal turbine technology. It is an extension of tidal turbine technology. A series of turbines are positioned in a row to form a fence through which water is passes, as shown in here. So if you see, there are number of tidal turbines are there, 1, 2, 3, 4, and they are connected, and from which the electric generator are there. For every turbine we have a generator, and from that the power gets there. So it is an extension of tidal turbine where series of turbine it is used and it forms a tidal fence. So all this forms a tidal fence. So tidal fence are constructed in channels between two land masses. The energy potential depends largely on the rate of flow, which is unique for each location. So this potential energy is depends on the flow rate of these tides. Now it is observed that uh, from little power generated when only few turbines are installed. So if we have one or two turbines, very little power is generated. Whereas when there is too many obstruction to the flow, that limits the power potential of this uh, tidal turbine or tidal fence. So there is, therefore, it is very much important to determine what are the optimum number of turbines and the location of this turbine, where to locate this turbine. So this is more important in case of this uh, tidal fence. So the fence installation are presumed to be less expensive. So installation of fence, it is less expensive to develop a tidal barrage, as well as it is less impacting to environmentals. So this is the third way by which we can produce the electricity, that is by using tidal fence. So it is an extension of tidal turbines. So number of turbines, tidal turbines connected together to form a fence. Now we have next part, that is the advantages and disadvantages of this tidal energy. So first advantage is, once tidal power plant constructor, the tidal power is free, because the input for tidal power plant, it is the tides, and in every day we have once or twice the tides are there, high and low tides will be there. Second, there is no greenhouse gases or waste are produces from this tidal power plant. Similarly, there is no fuel requirement. Then maintenance cost is also less, and the tides are totally predictable. We can predict the tides at which time there will be a high tide, at which time there will be a low tide, and in a day, uh, we can say once or twice tides are coming. So every day we can generate power by using this tidal power plant. Now, what are the disadvantages? First, if we use the tidal barrage, so a barrage across the estuary is very expensive to build inside the ocean. Second, the barrage affects very wide area of the ocean. The environment is changed for many miles upstream and downstream of the barrage. Because of this barrage, the nearby environment gets changed. Only provide power for around 10 hours each day, that when the tides is actually moving in or out. And there are few suitable sites for constructing a tidal barrage or dam inside the ocean. So these are the some disadvantages of this uh, tidal energy. So this is all about the what is meant by tidal energy and how we can convert tidal energy into electricity. That is how we can use the tidal energy for power generation. Now we have next part, that is the hydrogen energy. So hydrogen, it is a clean fuel that when consumed in fuel cell produces only water. So if you use hydrogen fuel cell, so when hydrogen is consumed, we produce only water. So byproduct of this hydrogen fuel cell, it is a water. So hydrogen can be produced from variety of domestic resources such as natural gas, nuclear power, then biomass, then renewable powers like solar, wind. So from which we can produce the hydrogen. So these qualities of this hydrogen energy make the hydrogen as an attractive fuel for transportation and for electricity generation application. So by using this hydrogen energy we can use for the transportation, like there are buses, vehicles. So any type of transport, it can be use this hydrogen energy. And also this hydrogen energy, it can be used for electricity generation also. So therefore, this hydrogen energy, it can be used in car, in houses, then for portable power, and many more application of this hydrogen energy. Again, the hydrogen is an energy carrier. So we can the hydrogen that can be used to store, move, and deliver the energy produced from other sources. So we can store this hydrogen energy, we can move this hydrogen energy, and we can deliver this hydrogen energy from other sources, one place to another place. Today, the hydrogen fuel produced by using several methods. So the most common method that is used to produce this hydrogen fuel, it is natural gas reforming. This is the first method by which we can produce the hydrogen, natural gas reforming. So that process is called as thermal process. And there is second process, that is the electrolysis process, by which we can produce the hydrogen. There are other methods also to produce the hydrogen as a fuel, like it may be a solar driven processes, or they may be a biological process of biomass. So by which we can produce the hydrogen as a fuel. Now we will see the first concept of this hydrogen as a fuel, that is hydrogen fuel cell. Hydrogen fuel cell. So hydrogen fuel cell, it is a device that generates electricity. So by using fuel cell, we can generate electricity by using chemical reaction. A hydrogen fuel cell, it is a device that generates the electricity by its chemical reaction. Now, every fuel cell, it has two electrodes. One, it is called as anode, and another, it is called as cathode. So, every fuel cell, it has two electrodes. One is anode, another is cathode. The reaction produces electricity that takes place at the electrodes. So all these reaction of producing hydrogen, it is takes place at these two electrodes, that is anode and cathode. Now every fuel cell, it also has an electrolyte which carries the electrically charged particles from one electrode to another electrode. So this is one important concept, that is every fuel cell requires or has an electrolyte, and the function of electrolyte is to carry the electrically charged particle from one electrode to another electrode. And third part, it is the catalyst. So a catalyst which speed up the reactions at the electrodes. So these three important parts of any hydrogen fuel, that is we have to require two electrodes, it may be anode and cathode. Second one is every fuel cell has electrolyte which carries the electrically charged particles from one electrode to another electrode. And third one is the catalyst which speed up the reaction at electrodes. Now hydrogen, it is a basic fuel, but fuel cell is also required oxygen. Now hydrogen, it is a basic fuel, but sometimes in this fuel cell, the hydrogen require oxygen, or we can say a fuel cell requires oxygen. So fuel cell generates the electricity with very little pollution. So very small amount of pollution will be there, and much of hydrogen and oxygen is used to generate the electricity, and ultimately when it combines together, hydrogen and oxygen, it forms a water. So byproduct of this hydrogen fuel cell, it is a water. Then a single fuel cell generates very small or tiny amount of DC electricity, direct current electricity, but many fuel cells are usually assembled into a stack where number of fuel cells are combined together and form a stack. These cells or stack having same principle as that of the fuel cell. So one of the fuel cell, it is shown in this figure, that is proton exchange membrane type of fuel cell. So in this, the first step is, so the hydrogen fuel is channeled through field flow plates to the anode. So this is the anode, this part is cathode. So cathode is positive terminal, anode is negative terminal, and in between anode and cathode we have polymer electrolyte. Polymer electrolyte membrane is there. So a hydrogen fuel is channeled through field flow of this plate to the anode of one side of the fuel cell, while oxidant, that is oxygen or air, is channeled to the cathode, that is other side of uh, fuel cell. So in this side, we channel the oxygen or oxidant, and from this side, the hydrogen gas will be flow or hydrogen will be flow. So from anode side, the hydrogen gas will be there, or hydrogen will be there, and from cathode side there will be oxygen. Now at anode, platinum catalyst is there that causes to split up this hydrogen into positive hydrogen ion, that is called as proton, and negatively charged ion, that is called as electron. So this hydrogen is get separated out into a positively charged ion, hydrogen ion, and negatively charged hydrogen ion, that is called as electron. So proton and electron, they are converted. Then the polymer electrolyte membrane allows only positively charged ions to pass through the cathode. So only H plus ion it is passed through this cathode, and the negatively charged electron must be travel along the external circuit to the cathode, and that will create the electricity. So at cathode, the electrons and positively charged hydrogen again combines with the oxygen, which forms the flow water, and this water gets flow out from this fuel cell. So this is a one type of membrane or fuel cell, that is the proton exchange type of membrane fuel cell. Now we have next working of this hydrogen fuel cell. So it is, we have a working. So for example, a fuel cell, the purpose of this fuel cell is to produce an electric current. Purpose of fuel cell is to produce electric current that can be directed outside the cell to do work such as powering of electric motor, or we can say illuminating a light bulb, or illuminating a city. A fuel cell is used to produce an electrical current, and that current is used for powering of the electric motor, or illuminating a light bulb, or illuminating a city. So because of the way electricity behaves, this current returns to fuel cell and completing electric circuit. So the chemical reaction that can be produces this current are key to how fuel cell works. So electrical current is produced from this fuel cell. It is the main key of this working principle of this hydrogen fuel cell. There are several kinds of fuel cell, or different types of fuel cell. That one of the fuel cell will be a proton exchange membrane type of fuel cell. Then we have alkali fuel cell. So there are number of fuel cells. Each operates a little bit differently. So working principle is same, but operation will be little bit different. But in general terms, the hydrogen atoms enter in a fuel cell at cathode, where there is a chemical reaction happens. So hydrogen atom, it is enters in a fuel cell at anode, where the chemical reaction happens, or chemical reaction strips them into an electrons, and the hydrogen atoms are now ionized. So H plus atom is there, and we have get another electron, that is E minus, at this cathode anode part, that split up of hydrogen atom into hydrogen ion and electron is there. So hydrogen ion, it is called as a proton, and this it is a electron. So the hydrogen atoms are now ionized and carry the positively electric charge. It carries positive electric charge. The negatively charged electrons provides the current through the wires, and this current, it can be used for any other purpose like powering of the electric motor or illuminating light bulb as shown in this figure. The oxygen. Now another, the oxygen enters in fuel cell at cathode. So from this oxygen from air, it enters in this cathode part, and it combines with this electron of returning from this electric circuit. So electron gets travel through this electric circuit and again return to this, and it is then combined with this oxygen, and which completes the electric circuit. And again hydrogen from this cathode, that is ionized, positively charged ion of hydrogen, that is proton, it is passes through this to anode. So hydrogen ion that have traveled through electrolyte from anode, so it will travel through electrolyte, and this negatively charged electron, it is passes through electrical circuit, and which produces the electricity or light bulb or light, or it will illuminate this light bulb. And the water gets exhausted from this cathode part or from the fuel cell. So if you see this hydrogen, it gets, if you see the positively charged ion of hydrogen, that is H plus, is directly passes through cathode to anode to cathode, from this anode part to cathode part, and negatively charged ion, it passes through this circuit which lights the lamp, and when it combines with this oxygen, it will produce the water, that is the H2O. So this is the working principle behind the hydrogen fuel cell. Now there are some other important characteristics, like we have electrolyte, then catalyst. So that we will see in next slide. So next part, it is the, now next, in other cell, oxygen picks up these electrons and then travel to the electrolyte to the anode, and that combine with the hydrogen ion. So the electrolyte must permits only appropriate ion to pass between anode and cathode. So electrolyte permits only positively charged ion to pass from anode to cathode, and the free electrons or other systems, they are could travel through the electrolyte, and that would disturb the chemical reaction. If it is passes through that electrolyte, it will disturb the chemical reaction. So whether they combine at anode or cathode, together hydrogen and oxygen forms the water, and that water can be drained out from the fuel cell. So as long as fuel cell is supplied with hydrogen and oxygen, it will generate the electricity. So we require hydrogen as a fuel, as well as we require oxygen or air, oxidant. So since fuel cells creates electricity chemically rather than the combustion, so in fuel like oil, that is petrol, diesel, coal, we have to burn that fuel and combustion will be there. So they are not subject to any thermodynamics laws or limits to conventional power plant like Carnot limit or Carnot cycle limit, because it produces electricity by chemical reaction. So therefore, the fuel cell is more efficient for extracting the energy from fuel. And the waste heat from some cells, it can be harnessed or it can be used for boosting the system efficiency still further. So this is the working principle or working behind the hydrogen fuel cell. Now the next part is there are different types of hydrogen fuel cell. So one of the famous example that is AFC, alkali fuel cell. Then we have molten carbonate fuel cell that is called as MCFC, molten carbonate fuel cell. This is alkali fuel cell. It is called as AFC. A is stand for alkali, F is fuel, and C is cell. Then we have another type of fuel cell that is phosphoric acid fuel cell, PAFC. Then we have seen this proton exchange membrane type of fuel cell that is PEM. And we have another type that is solid oxide fuel cell that is SOFC. Now, out of which we see one of the fuel cell that is called as alkali fuel cell, AFC. We have seen this proton exchange membrane fuel cell. Now we will see this alkali fuel cell. So alkali fuel cell operates on compressed oxygen and hydrogen. So in this fuel cell, we require hydrogen and oxygen should be compressed. So for that, we use a potassium hydroxide KOH in water as an electrolyte. So any fuel cell, we require fuel, oxygen, that is anode cathode, catalyst, and electrolyte. So in this case, alkali fuel cell, we use potassium hydroxide in water as an electrolyte. So this is anode part, this is cathode part, and this is electrolyte part. So electrolyte is a solution of potassium hydroxide in the water. So oxygen is passing from this side, the hydrogen fuel passing from this side. So hydrogen, it is split up into positively charged ion and negatively charged electron. This negatively charged electron, it is cannot pass through this catalyst electrolyte part. So it is flow through this electrical circuit and it will produce the electricity in this side. The positively charged ions and this oxygen, it is travel and it is combined with the positively charged of this hydrogen and it will forms the water, that is H2O, and water gets outside from this fuel cell like this. So the efficiency of this fuel cell, it is about 70%, and the operating temperature is also very low, that is up to 150 degree to 200 degrees Celsius, that is about 300 to 400 degree Fahrenheit. The operating temperature is that. And this alkali fuel cells output is ranges from 300 watt to 5 kilowatt. So single fuel cell produces this amount of electricity, that is from, or we can say power, that is 300 watt to 5 kilowatt. The alkali fuel cell were used in Apollo spacecraft to provide both electricity as well as drinking water. It is first used in Apollo spacecraft, which provides the electricity as well as drinking water. This alkali fuel cell is require a pure hydrogen fuel, and their platinum electrode catalysts are expensive. In this, we use catalyst as platinum catalyst, and they are more expensive. And like any other container filled with liquid, this fuel cell also can be leaked because these are filled with the liquid. So their leakage problem will be there in case of this alkali fuel cell or in a fuel cell. So this is all about the two types of energy. One is tidal energy and second one is the hydrogen energy. So thank you for listening these videos, and please do subscribe my channel so that you get other videos of this introduction to energy sources as well as for this subject of systems in mechanical engineering. Thank you very much.